for this one, okay, so explain the meaning of the term electronegativity. So can we have Arwen to actually tell us what is the meaning? Okay, Arwen, what do you understand about this term electronegativity?
The ability to attract electrons from covalently bonded molecules.
Okay, very good. Okay, so it's the ability, okay, of atom to attract covalently bonded electrons, electron pair to itself. So this is what we want to see. Okay, we want to see that, okay, the electron, the bonding pair of electrons are being attracted, okay, towards itself. Okay, so now draw the correct dipoles on the following covalent bonds. Okay, so how do we draw, okay, these correct dipoles? We need to refer to your periodic table. Okay, so in this case, okay, let's actually have a look at Cl and Cl. Okay, do you have any dipole for Cl and Cl, Christopher?
It's going to be like in the middle, right? So it's going
Yes,
to be
so
covalent.
basically, yeah, what we can say, because they say draw the correct dipoles, okay, it means there is no dipole over here because the electron will pull either here and then the electron will pull over there, then the both moment cancel with each other. So it means here I can actually say no dipole. Okay, no dipole. Okay, for H and OH, Jasmine, can you tell me if you compare H and O, which one do you think the dipole will be?
Oxygen.
Okay, oxygen. Okay, so the dipole is going to go towards there. Okay, towards oxygen. The electrons, okay, will actually go towards oxygen. So which one is going to be the dipole here? This is going to be delta negative, and this is going to be delta positive. Okay, please do this. Okay, how about BF? Hold on, yeah. Okay, if you have B and F, okay, B and F, okay, if you have boron and fluorine, okay, which one do you think, okay, will give you the dipole? Given?
Fluorine.
Yeah, why? Can you tell me why roughly?
Because fluorine has more protons, so the force of attraction is larger.
Okay, are they belong to the same period? Boron and fluorine?
Yes.
Okay, if they are in the same period, okay, it means the only thing that is going to affect over here is going to be more number of proton. Yeah. So when you go across the periodic table, the right hand side elements will generally have a greater electronegativity. So this one, okay, if I put it as a periodic table, so as you go across, okay, to the right hand side, okay, so you have the electronegativity is going to increase, but here, okay, as you go down the group, we can say the electronegativity decreases. Okay, the reason is the distance and the shielding effect, because there is going to be more shells, okay, that will be added over there. So the distance and shielding effect will outweigh, okay, will outweigh the increase in the proton. So this one is actually almost similar to your ionization energy also. Okay, why? Okay, why you need, as you go down, the ionization energy is getting smaller. Okay, the ionization energy getting weaker because the increase in the distance and shielding effect will outweigh the increase in the proton. So it's much more easier to remove those electrons as well. So this one is quite related, okay, to ionization energy. Similar, yeah. So ionization energy, when you go across the periodic table, the ionization energy is going to be getting higher, and ionization energy over here is getting lower. Okay, it's the energy needed to remove one electron from the gaseous atom. Okay, so similar to that. So now, okay, this one is delta negative, delta positive. Okay, nitrogen and F. So which one do you think will be more electronegative, Audrey?
F.
F, okay, because they're in the same period, yeah. So this is delta negative, this is delta positive. They will go there. Nitrogen and O. Michael,
Oxygen.
oxygen, okay. Also from the same period, oxygen is going to be towards the right hand side, so they will go there. So delta negative, delta positive. Okay, these are the things that they want. This one I have already taught you, HCl. Okay, hydrogen is the least electronegative. Okay, Cl, okay, they will go there. So it's going to be delta negative, delta positive. So you don't need to even check. Okay, for H and N, the same thing. Hydrogen is going to be the least electronegative compared to anything else. So this is delta negative, delta positive. Okay, I want to also highlight between carbon and hydrogen. Imagine like if you have a maths test, for example, and I told you the one that has a highest results, 100% must be the one that is highest ability. Okay, maybe 0% is the lowest ability. And I told you the lowest ability is the one that is going to be hydrogen, for example. Okay, they have found out that carbon is almost similar to hydrogen. Let's say they get 1% mark only. Okay, so they say that carbon is also similar to hydrogen, okay, which is closer to zero. Okay, therefore, the electronegativity between carbon and hydrogen, they have mentioned that they have similar electronegativity. So if you look at C and H, we can always say there is no dipole. So it's a special case also. Carbon and hydrogen, okay, they do not have any dipole between them. That's the reason, okay, if you have hydrocarbon, okay, most of the hydrocarbon, they are not soluble in water, okay, because they don't have any dipole. Okay, so we will come into that later. Okay, but now, okay, B and H, I think this one you should know also. It will go towards boron. Okay, hydrogen is the weakest. So this one is going to be delta negative, delta positive. Okay, whenever the electron moves to one place, that's the part where it will become delta negative. Okay. Now draw the following molecules, add dipoles to all the bonds, predict whether or not they have overall dipole. Now, they didn't say draw the cross dot diagram, so I will just simply draw. Okay, carbon, 4 valence electron. Okay, I will have something like this. So I will have like this. Okay, so it means rather than actually drawing everything in a cross dot diagram, I know that there is no lone pair of electrons, so I can simplify by just drawing like this. Okay, this is also the same. And then I want to actually see whether there is overall dipoles. Okay, what happens? The electron will go here, electron will go here. So this one is going to be delta negative. This is supposed to be delta negative. Okay, so here add dipoles to all the bonds. Okay, so this bond, yeah, so this one is delta positive. This part is delta positive. Predict whether or not they have overall dipole. Okay, overall dipole is going to be 0 because the dipole moment cancels with each other. Okay, but before you do this, you need to make sure that they do not have any lone pair of electron. Now for SO2, okay, it's not in your syllabus to learn how to draw SO2, but I will just tell you sulfur, okay, just imagine it's going to be double bond. It will form a double bond with oxygen and oxygen. But I want you guys using this drawing, I want you guys to determine for me whether sulfur has any lone pair of electrons. Sulfur is in which group? Megan, sulfur is in which group?
6.
Okay, so sulfur 6 valence electron. So here, if you have double bond, it means they have like this, okay, sharing with oxygen. So it means there's another 2 more electrons over there. So there is lone pair of electron. Okay, there's lone pair of electron. So if I want to actually draw the dipole, okay, so of course the oxygen and sulfur, which one do you think will have, okay, which one is more electronegative, sulfur or oxygen? Sulfur is,
Oxygen.
okay, oxygen is on top, right? Okay, if you look at your periodic table, wait, yeah, Owen say, is it sulfur? Okay, look at your periodic table. Sulfur and oxygen. Okay, you see, it's oxygen is on top of sulfur. Oxygen, sulfur, they are from the same group. So we know that as you go down the group, what can you say about the electronegativity? Michelle?
Going down.
Going down. Electronegativity decreases. It means that oxygen has greater electronegativity compared to sulfur. Okay, so this one, electronegativity is weaker. Okay, this one is stronger. So electron will go there. So the this is delta positive. Sorry, delta negative. Okay, delta negative. And do remember, okay, there is going to be a presence of lone pair of electron. The moment there is lone pair of electron, that molecule is not going to be no longer going to be symmetrical. So the dipole moments cannot cancel with each other. Okay, therefore, okay, we say, okay, this is going to be dipole. Okay, it has dipole, so we can actually we can say, rather than just putting it as dipole, I'll put it as polar molecule. This is polar. This one is non-polar. Okay, this is what we want to actually identify. So let's actually try to identify for BF3. A boron, which group? Juliano?
I think group 3.
Okay, group 13, so 3 valence electron. Do you think there is any lone pair of electrons surrounding boron?
I don't think so.
Yeah, because all the 3 already involved in the bonding. Okay, so there won't be any lone pair of electron. So this one is a symmetrical molecule. Now I want to actually identify between boron and fluorine, which one is going to be more electronegative. Okay, Wilson, can you tell me which one is more electronegative? You can refer to your periodic table.
Fluorine, I think.
Fluorine, because fluorine is at the right hand side, okay, of the periodic table. They are in the same period. So we know that the electron will go there. Okay, the electron will go here, the electron will go here, making this delta negative, delta negative, delta negative, delta positive, delta positive, delta positive. But okay, what happens even though the bond is polar, okay, the dipole moment cancels with each other, the overall dipole is zero. Okay, because they are going to be going and cancel with each other. It's a symmetrical molecule. Therefore, I can say that this is going to be non-polar. NF3. Frederick, nitrogen is from which group?
Nitrogen is from group 15.
Okay. Do you think nitrogen will have lone pair of electron in this molecule?
No.
Why no, Frederick? If you have group 15, they have 5 valence electron.
Yeah.
One of the electron went over here, another electron went over here, another electron went over here. So where the remaining 2 electrons? You'll be there. So there is a lone pair of electron. Okay, there is a lone pair of electron. Therefore, okay, it means, of course, this one is X here. Okay, belongs to fluorine. So anyway, there is a lone pair of electron. So whether this molecule is symmetrical or non-symmetrical, definitely it is non-symmetrical. The shape is similar to ammonia, pyramidal shape. Okay, so whether this is polar or non-polar, okay, N and F, okay, you know that F, okay, is going to be more electronegative. Okay, and what happens, okay, hold on, yeah, it's not actually showing on the screen. Can you guys hear me? I'll try to share the screen again. Okay, it's not sharing the screen properly. Okay, so okay, it's a bit slow. Okay, anyway, you will see that, okay, you will see that the fluorine, okay, being actually the electron pair will go towards fluorine, but because there is a presence of lone pair of electron, okay, that makes the molecule, okay, the dipole moment, they do not get cancelled to each other. Okay, it's not going to 3 direction just like trigonal planar. Okay, it's not going to be cancelled to each other. So it will actually be like something like because of the presence of lone pair of electron, okay, this molecule is going to be polar. Okay, that is overall dipole. How about Cl2? I think very easy. Catherine, do you think Cl2 is polar or non-polar?
Non-polar.
Yeah, it's non-polar. Okay, because same electronegativity. Okay, HCl, I think very easy. Okay, HCl. Cl is going to be more electronegative than hydrogen. So they will pull the electron towards Cl. Delta negative, delta positive. So definitely going to be polar. Okay. Do you have any questions up to here? I think we have done it together.